All right. So y'all see the objective today is to solve equations, the learning target, right? Not equations, solve inequalities, which we'll talk about in a minute. But the warm-up is just solving another multi-step equation. So notice there's two things due. They're above me here, the 19th and the 20th. You got them Monday and Tuesday. And then quiz is going to be on Friday, solving equations and inequalities, which is what we will learn today. First, this warm-up, do you see that there's like three different x's? There's a 5x, a minus 7x, and a 3x. And then two of them are on the left side, right? So what do I do with 5x and minus 7x? If they're on the same side, do I combine them or get rid of one? What do y'all think? Combine like terms. So 5x minus 7x is negative 2x, okay? Bring down the extra constant term. Now, when you bring it down, it's not just a 2, there's a minus sign with it, right? So it's minus 2 equals, bring down 3x plus 8. Cool. Now, x is on both sides. Do I combine them or get rid of one? Who thinks we combine them? Who thinks we get rid of one? Okay, so when they're on different sides, that's when you get rid of the smaller x, okay? Which x is smaller? Well, 3x, the other one is negative 2x. Which one's smaller? Negative 2x, right? The opposite of negative 2x is adding 2x to both sides. Now, careful, when you bring this down, again, it's negative 2. 3x plus 2x is 5x. And then bring down plus 8. So now this is a two-step equation. On the right side, I've got a loner, 8. How do I get rid of that positive 8? The opposite is to subtract 8. Negative 2 minus 8 is negative 10. And then bring that 5x over here. And then to get rid of the 5 in front of x, divide by 5, divide by 5. Negative 10 divided by 5 is negative 2. Okay. Now, everything we've learned so far for solving equations, we're going to use it on solving inequalities. It's going to be very similar. There's just going to be a few things we need to know. So let me pass this out. Oh my gosh. One second.
What?
Ready. All right. Have y'all seen these inequality signs before? Less than, greater than. Okay, so you got to be able to identify. You have to actually know this stuff. You're not going to have like a reference sheet that tells you which one's less, which one's greater. So there's an easy way to just know by looking at it whether it's a less than or a greater than sign. Okay? So above less than, can you draw a less than sign? Okay. Now, how do I know that's a less than sign? Well, one way is that it kind of looks like an L. Less than. Isn't that a cool trick? Looks like an L, it's a less than sign. Another way to remember that is that it's pointing to the left. Left pointing is less than, right? And maybe you've heard this before, middle school or something, but it's pointing to the smaller one, it's opening up to the bigger one. Some people talk about Pac-Man, alligator mouth, eating the bigger number. That's fine. But you got to know how to say the symbol. So if it looks like an L pointing to the left, that's a less than sign. Cool? What about the other one? Now, does that look like a G? No, right? Unless, watch this. Kind of looks like a G now, right? Let me try that again. Hey, so my greater than sign, if I put a little curve on it, looks like a G. G for greater. Okay? That's the trick. Now, which way is it pointing? It's pointing to the right where all the greater numbers are. You know on a number line, the greater numbers go to the right. So it's pointing to the greater numbers to the right. It's opening to the left. Okay? Eating the smaller one. Okay, so if it points to the right, that's a greater than sign. You got to know which one's which. So again, less than looks like an L, greater than points to the right, and you can make a G out of it. Now, what if they're underlined? So if it's underlined, it's also equal to. It's underlined, it's also equal to. Sometimes you include the number, and sometimes you exclude the number. So the inequality will tell you whether you include it or exclude it. Okay? Now, numbers, all the numbers you can think of are mostly not equal to each other. Obviously, they're different. So that's why we use inequalities to show one is smaller or bigger than the other. So we're going to do a little exercise here. We're going to use two numbers, -2 and 4. And first we're going to write the inequality, but then we're going to apply some operations to see if it stays the same inequality. So first things first, write an inequality. -2 and 4. Is -2 less than or greater than 4? Less than, right? How do I write a less than sign? Well, looks like an L. Points to the left. It opens to the bigger one, right? Pac-Man mouth, whatever. So -2 is less than 4. That should be easy. That's like not high school level. That's obvious. Here's where we got to know how to use algebra. What if we use some operations? So let's start with multiplying. If we multiply both of those numbers by 3, let's see what we get. -2 times 3, 4 times 3. So -2 times 3 is -6, and 4 times 3 is 12. Okay, now if I use -6 and 12, and I write it here, -6 less than 12, off to the right, the third column, or the last column, is it true? Is it still true that -6 is less than 12? What do y'all think? Yes, like -6 is less than 12, it's smaller, it's negative, 12 is positive, it's definitely less than, right? So go ahead and write true. It's true. Okay, what if we don't multiply by 3? What if we multiply by -3? Let's try that. So -2 times -3 is -6. Not -6, my bad. Negative times a negative is a +6. And what about 4 times -3? Well, that's -12. Okay. So we got 6 and -12. Let's write that out. 6 less than -12. And now here's the question. Is 6 less than, is 6 smaller than -12? Is a positive number smaller than a negative number? No, right? Does everyone know this? Okay. So 6 is not less than -12. That is false, right? False. So let's rewrite it correctly. 6 is actually greater than -12. Okay, opens up to the bigger one, points to the smaller one. Let's try with division. When you divide by 2, so let's do -2 divided by 2 and 4 divided by 2, we get -1 and 2. Let's go ahead and see, is it true? Is negative 1 still less than 2? Yes or no? It is true. Negative 1 is definitely smaller than a positive 2. Okay, true. One more example. What if we divide by a negative 2? So negative 2 divided by negative 2. Negative divided by negative is a positive 1. And 4 divided by negative 2. 4 over negative 2 is negative 2. All it did was change the signs, so let's rewrite it. 1 less than negative 2. Is that true? No, a positive is greater than a negative, right? So this is false. 1 is greater than negative 2. Right. The one I just rewrote, that is true, but the third column is false. Okay, now you'll notice some are true, some are false. What is the common thing you notice about these false ones here and here? What kind of number did we multiply or divide by? Y'all see those negative signs, right? So when I multiplied by a negative or I divided by a negative, it turned out false. So what we're going to do is make a little plan right here, or a little rule, I should say. Okay, let's go ahead and write this down. When solving an inequality, if you multiply or divide by a negative, you must flip the direction of the inequality sign. All right, so that's the rule for today. It's just like today is just like solving equations, but there's an inequality sign. The main thing we got to know is when do we flip it. So look at example 1 here. Y'all ready? It's already filled out, so you don't have to write it, but I want you to look. Is everyone looking right here? Example 1, negative 3c plus 3 less than negative 15. First thing I need to get rid of is the loner plus 3 by subtracting 3, right? So they cancel out, and I do it on both sides. Negative 15 minus 3 is negative 18. Now, last step. To get rid of any number in front of the variable, any coefficient, you have to divide, right? Negative 3 and c are multiplying, so we have to do the opposite. Divide by the exact same number, negative 3. So look, the negative 3 on the top and bottom cancel out. Now I just have c. Negative 18 divided by negative 3 is positive 6. But look, didn't we divide by a negative on this problem? Like right here, this is dividing by a negative. Since we divided by a negative, we had to flip the inequality. Do you see how it went from less than to greater than? Right? That's very, very, very important. If you do not flip it when you're supposed to, you'll get the wrong answer. Okay? Only when you multiply or divide by a negative number. Cool. Flip it over, please. Let's look at example 2. This one is also typed out. Let's talk about it. Y is here, so the loner is minus 7. The opposite is to add 7. So the 7s cancel out. 19 plus 7 is 26. Now, what's the opposite of dividing by 2? Multiplying by 2, right? So times 2 here, times 2 here. So we end up scratching out those 2's, y, and then on the other side we have 52. Now, did we multiply by a negative? No, we multiplied by a positive 2. So this one does not flip. Y'all see that right here? This stayed greater than or equal to the entire time. Cool? You only flip it when you multiply or divide by a negative number. Okay? Let's try some examples together, and then I'll let you work. First one on the top left here. 7w minus 4 is less than or equal to 17. I want to get w by itself. What's the loner I need to get rid of? The minus 4. What's the opposite of minus 4? Plus 4. Bring down 7w, less than or equal to. 17 plus 4 is 21. Last step, how do I get rid of the 7 in front of w? It's a coefficient, so we divide by 7, divide by 7. Now, do I flip the inequality? What do y'all think? I divided by a positive, so it's going to stay the same. I did not divide by a negative. 21 divided by 7 is 3. Okay. Now, I told you there's two reasons to flip it, right? Multiplying by a negative, dividing by a negative. Here's one more. Ready? What if you have multiple choice where the w is on the other side? What would you have to do to put w on the other side? So let me show you. Ready? You can put w on the right. You can put 3 on the left. But what do you think happens to that inequality if you flip the whole thing over? For it to stay true, you have to flip the inequality as well. So the less than becomes greater than. This is true, or this is true. They're both true. You can literally flip the entire inequality if you want to, but if you flip everything, you're going to have to flip that inequality, okay? So if you flip the whole thing, then you must flip the inequality sign. If you flip the whole thing, flip the inequality sign. Okie dokie. Off to the right here, the loner is 3, a plus 3, so we're going to do the opposite. Minus 3, minus 3. R over negative 5 is greater than 12 minus 3 is 9. How do I get rid of a divided by negative 5? What's the opposite? Opposite of dividing is multiplying. Negative 5, multiplying negative 5. So now I have R. 9 times negative 5 is negative 45. Do I flip the inequality sign? So let's think about it. I multiplied by a negative. So again, that is one of the situations where you got to flip the inequality. So greater than becomes less than. Let's do better than that. Okay. You flip it because you multiplied by a negative. Okay. Down here, the loner, here's x, here's the coefficient, 4 is the loner. 4 is positive. The opposite of that is to subtract 4. Subtract 4. Bring down negative 2/3 x greater than 11 minus 4 is 7. All right, and then let's see what you remember from last week. What's the opposite of a fraction? How do you do an opposite of a fraction? I have 2 over 3. What would the opposite be? So we went over this last week. The opposite of a fraction is its reciprocal, where you flip it. Okay, so again, if you see a fraction, you multiply by the flip. So if I flip negative 2 over 3, I get times negative 3 over 2. The negative sign, the sign stays the same. It's just flipping the fraction, okay? If I do it on the left, I'm going to do it on the right. On the left side, the negatives cancel out, the 3's cancel out, the 2's cancel out. Now I just have x. And everybody, since I multiplied by a negative, it's going to flip the inequality sign from greater to less than. And then 7 times negative 3 over 2 is negative 21 over 2. You could write it as a fraction, a decimal, sorry, negative 10.5, but that's fine. Last one, I'm going to do this real quick. You distribute, you get rid of that loner, and then you divide. Since you divided by a positive, you should get the same inequality. It stays less than or equal to, okay? Okay, everybody, I'm going to give you an assignment for solving inequalities. Look right here. I need you to finish Monday's, actually finish last week's 2 assignments if you haven't, but you need to finish Monday's assignment first, yesterday's assignment that you grabbed on next to the turn-in bin. If you didn't get yesterday's assignment, it's in the blue bin. It'll say 820. Solving equations, mixed practice, in the blue bin. This is the second thing you do this week. And then today, you're getting an inequalities worksheet. That might seem like a lot. I understand. You have time today, and then we're going to spill it into tomorrow. I'm going to give you class time to work on it, okay? So as long as you're actually working, I think you'll be all right, okay? So let's go ahead and get started for today.